All right, let's jump right in. Welcome to today's Explainer, where we're going to explore how one single, seemingly magical date basically connects the stars up in the sky, the global internet we use every day, and, well, the gadgets right there in your pocket. I know, it sounds totally unbelievable, right? But history has a really funny way of lining things up. So take a look at these three things: our smartphones, a distant lighthouse, and the stars in the night sky. What could they possibly share? Well, it turns out the absolute masterminds behind the math powering all of these modern marvels happen to share exactly the same birth or death date. Yep, May 10th. Today we're tracing this wild mathematical golden thread right across the centuries. Here's our timeline, forming a kind of rapid-fire carousel of brilliant builders. We're spanning from 1788 all the way to 1953, and every single person we're going to talk about today is linked to this exact date. What's truly fascinating here is how their incredibly complex, abstract math became the literal, invisible foundation of the tech we literally cannot live without today. So let's meet our first genius. Think about a lighthouse beam cutting through a dark storm, or maybe just that flawless autofocus on your smartphone camera lens. How do they work so perfectly? Well, we're starting our time travel with Augustin Fresnel, who was born on May 10th, 1788. Before he came along, the scientific world was fiercely debating how light actually behaved. But Fresnel, he cracked the code. His wave theory of light changed the whole game. He proved that light actually travels in waves by showing exactly how it bends around edges, a process called diffraction. And then he took that abstract math and invented compound lenses for lighthouses, which ended up saving just countless lives at sea. So, every single time we snap a selfie today, we're capturing memories using principles discovered by a guy born way back in 1788. How cool is that? Okay, moving on. How do our factory robots or even our 3D video games understand complex space and movement? Jumping forward a bit, we meet Wilhelm Killing, born May 10th, 1847. Now, get this. He was a mathematician working completely without computers. I mean, obviously, right? Yet he managed to map out insanely complex geometric spaces using what we now call Lie algebras. It's essentially a mathematical toolkit for studying continuous smooth symmetries. His work systematically classified these algebras to study non-Euclidean geometry. At the time, this was pure abstract thought, basically math for math's sake. But today, our modern physics and robotics use his exact mathematical framework to navigate our three-dimensional world. The hidden shapes of our universe were literally mapped out before a single computer even existed. It's just mind-blowing. Now, from moving through space, let's turn to the invisible waves traveling all around us. Ever wonder how the wireless signals reaching our phones manage to bend perfectly around thick concrete buildings? Next up is Bevan Braithwaite Baker, born May 10th, 1890. He actually started out in physics but found his true calling in mathematics, helping us map exactly how waves of sound and light propagate or travel through open space. He quite literally wrote the book on the mathematical theory of wave propagation. His work perfectly explains the precise principles of diffraction, which is the science that allows Wi-Fi and cell signals to bend right around walls and stream directly into our living rooms. Every single wireless ping that hits your phone right now is riding on Baker's math. So how does Google Maps instantly find the absolute fastest route in a busy, gridlocked city? Well, born May 10th, 1899, Otakar Borůvka was a brilliant Czech mathematician. The story goes that a friend of his who worked for a power company came to him with a massive headache. The problem was, what's the most economical way to string an electrical network across multiple cities? This very real-world headache led Borůvka to invent what we now call the minimal spanning tree problem. And what started as just a simple, practical problem about connecting dots with the absolute minimum amount of wire became incredibly powerful. Today, this exact logic forms the backbone of internet routing and modern GPS maps. When your phone calculates the quickest way home to avoid traffic, it's using Borůvka's logic. So the blueprint for our entire digital internet was actually born from a math problem about electrical grids. Pretty wild, right? All right, have you ever looked up and wondered exactly what the stars in the night sky are actually made of? Arriving at May 10th, 1900, we meet astronomer Cecilia Payne-Gaposchkin. When she was at university, the scientific establishment absolutely insisted that stars were made of the exact same heavy elements we find here on Earth. But she looked closely at the data and bravely proved them all wrong. She showed that stars are overwhelmingly made of hydrogen and helium.
Her data proved that hydrogen is millions of times more abundant than any other element in space. Now, at first, senior astronomers flat out rejected her findings, but she was completely right. Her work overturned decades of established scientific consensus and ended up laying the foundation for all modern astrophysics. Thanks to her, we know our universe is secretly made up of basically just hydrogen and math.
Okay, stepping down from the stars and into the microscopic world, how do we predict the wildly chaotic paths of particles in quantum physics? Born May 10, 1904, Edward McShane was a mathematician who completely loved tackling the unpredictable. He mastered something called the calculus of variations, which is the math of finding optimal paths to model events that just seem completely random. He essentially created stochastic calculus, basically probability-based math, to handle these highly chaotic systems. During World War II, he even applied these very formulas to exterior ballistics, calculating optimal flight paths for projectiles. Today, his integration processes are absolutely vital for untangling complex quantum physics. He found a way to tame the wildest, most unpredictable movements in nature, all by using pure math. Now, imagine trying to find the 10 billionth digit of pi. Do we really have to sit there and calculate all 9,999,999,999 numbers before it? Our final mathematical builder born on this day is Peter Borwein, born May 10, 1953. For centuries, calculating that infinite number, pi, was just a slow, agonizing, step-by-step process. But Borwein and his team, they completely flipped the script. Instead of a linear crawling calculation, his team developed the Bailey-Borwein-Plouffe formula. This staggering algorithm lets us jump straight to the nth hexadecimal digit of pi without needing a single one of the preceding digits. Today, supercomputers use these intense, targeted calculations to test their own processing speed and accuracy. They are quite literally cracking the infinite code of pi just one isolated digit at a time. Okay, so how do we know that light acts exactly like ocean waves crashing onto a beach? Well, now we shift our focus to the brilliant minds who actually left us on this exact day. We'll start with Thomas Young, who died on May 10, 1829. He was this brilliant English mathematician and physicist who conclusively proved that light creates interference pattern. Young used diffraction to determine the actual wavelength of different colors. He showed that light waves interact, they overlap, and they crash into each other, exactly like ripples intersecting in a pond. His foundational work on physical optics paved the way for lasers and the bright digital screens we all stare at every single day. So every colorful image on your screen right now relies directly on his understanding of crashing light waves. And finally, how do massive amounts of internet data travel thousands of miles across the ocean floor without losing their shape or just completely scattering? We honor Diederik Korteweg, who passed away on May 10, 1941. This Dutch mathematician became completely obsessed with how waves move in water. And alongside his student, he co-discovered a mathematical equation for solitary waves that simply never dissipate. The Korteweg de Vries equation perfectly describes these rogue solitary waves that just stubbornly hold their tight shape over massive distances. Fast forward to today, this exact mathematical principle is what keeps our fiber optic internet signals tightly packed and fully intact as they shoot across the globe. Yep, the secret to our high-speed global internet was hiding in the math of solitary ocean waves the whole time. So, we've seen how the brilliant minds born and lost on this single remarkable date shaped the very fabric of the technology we use every single day. From the composition of the stars above us to the maps guiding our phones, it is all intricately, beautifully connected to May 10th. It kind of makes you wonder, what incredible, world-changing things will we discover today? Thanks so much for exploring with us. Keep questioning and keep learning.